All right, so I'm Michael Stock. When did I meet John? I think I met John at a random conference. I didn't know who he was. He was still working for some random laboratory in Colorado. I don't know, some small place that nobody's ever heard of. It was not very small. And I was talking to him about instrumentation, and I didn't talk to him again for years. It's pretty much how that went. And I met him again when I got back to Oklahoma. It's kind of interesting because somewhere in the middle there, I was looking for a John, and I didn't know that John had made a profession out of doing the things that I was looking for somebody to do. So I never hired him. And I continue to never hire him sometimes. That's not true. John's great. So I'm Michael Stock. I have been doing measurements and instrumentation for like 20 years or something like that. It's always kind of scary when I start thinking back at when I started this. It was a long time ago, as it turns out. And I've done a lot of weird things. These are all photos I took on field deployments. So these are actually me taking measurements. I actually went out to Wallops Island. I was trying to measure radio frequency emission from contrails off rockets because, of course, why wouldn't you do that? The one in the middle there, that is Sakurajima erupting. We were looking for small sparks. And all of this is sort of related to this thing on the right. That is a photo of Huntsville, Alabama, during the GLM Science CalVal campaign. And somehow or another, I got into doing lightning a long time ago. And lightning has been pretty awesome because it uses a lot of small little instruments that basically you can build yourself, which is great. And somehow you can do some real science with it. So I'm going to tell you some stories. I'm going to start out with a cheesy parable here, which I definitely hand illustrated. So once there was a dapper scientist. We need a name for this dapper scientist. We'll name him, I don't know, we'll name him John for now. And John was hauling a load of scientific enlightenment to market.
I have not seen this presentation before.
So if it's bad, it's John Blackman.
Unfortunately, after not too long, he reached a vast chasm, the chasm of measurement. But unperturbed, John said, you know what? Somebody's got to have built a bridge across this chasm. I'll just go find it. And sure enough, there was a bridge. Unfortunately, it was old and rickety and not looking all that great. And there was a toll to use it. But John was unperturbed. He said, whatever, I'll pay the toll. I'm going to cross this bridge. I'm going to get my stuff to market. Only his cart didn't fit. And so John became stuck on the bridge, and he never did get his enlightenment to market. But don't worry, there was another young scientist. We'll name her, I don't know, Shannon.
No eye contact.
Also trying to haul her load of scientific enlightenment to market.
She does have a flannel on it.
Right? Slightly less dapper, but you know, that's all right. That just means a real scientist, right? And she also came to this same chasm of measurement. And you can definitely tell here, we're going to deviate from the truth here a little bit because Shannon said, you know what? I don't need a bridge. I can build my own damn bridge. And so she did. And some say she's still building that bridge to this day. This kind of comes into the theme of probably what I'm going to talk to you about. Do you want to build it or do you want to buy it? And the answer is both are bad. Because if you buy it, you're going to get something quicker. It's probably not going to be more expensive, but it'll be quicker, but you're going to have to make compromises. Because the truth is that every one of you here are trying to do some form of novel measurement. You're trying to do new science that somebody has not done before. So why in the world has somebody already built your instrument? They probably haven't, because what people in industry don't do is they don't build a random instrument that they don't have a buyer for and then hope that a buyer shows up. Not how it works. No. On the other hand, if you go and try and build the dang thing yourself, you're never going to finish. The more of it you try and do yourself, the longer it's going to take. Buying stuff is faster, but it's going to come with compromises. Building stuff is going to come with a different set of compromises because you have to build it. So it's not like you're not going to have to make compromises, but you have a little bit more control over where those compromises are. All it costs is all of your time. So yeah, your best option is going to be somewhere in the middle. And this is a younger, dumber scientist, a little bit crabbier. That's me. And I was tasked with building an instrument. These were some radio frequency antennas. So these are the antennas right here. This is where they were deployed. There's a cameo there on the right. That's Jackie's boss. Right now, that's Jeff up here. You'll notice that in front here, that is one of those, I think it's a fast antenna. It might be a slow antenna. Yeah, we lived in a trailer for the summer, that trailer on the right. So we're trying to build this instrument. This is going into some digitizer. We had the digitizer already. We had some version of the software for it. And for the first year of measurement, we had borrowed somebody else's set of electronics, and then we had to build our own. That's fine. How hard could that be, right? And it turns out it wasn't too bad. This is the final version of this thing. There's only really 2 custom circuits, and I definitely put custom in quotes here because this is really pretty dumb, simple stuff. Down here we have a power distribution board. This is taking power from here, and literally it's just wires going to 4 little connections that I can then connect here to power the antenna. That's it. It's just really some wires, conveniently held on a circuit board. And then over here, in the antenna itself, this thing is the bottom of this. This is your antenna housing. We have this board right here, and that is a regulator. It basically takes that voltage and produces something that these components here know what to do with. Everything else here was basically not quite off-the-shelf components. These are from mini circuits. We just bought them. These guys here are from Microwave Filter Company. They make great filters at exorbitant cost. They're very expensive, but they work. And they're really expensive because basically you tell them what they want, and they're like, yeah, we can do that. Frank will, hand wind this thing for you tomorrow. And that takes time, and that's the money portion of it. But we built these, and the system worked. So this is a picture of lightning that I got with this instrument. It did absolutely great. So in addition to that, we actually got some publications out of this. We published some papers. This is a fantastically successful instrument, right? So, all right, we're done. That's the story. We stop here. Everybody's happy. There's no real issues. But the actual story I want to tell you starts in the next step where I made another dumb move, and I moved to Japan. And the goal in Japan was to rebuild this instrument and make it a bit better. The guy I was being hired by at the time, who was paying my postdoc salary, sort of wanted to turn this into a semi-operational system that was no longer just made out of nuts and bolts we had lying around the lab, plus some mini circuits components, and turn it into something that could actually run operationally in real time for a long time. I think it was kind of daft, but he was paying my salary, and so what we did is we put together this thing. Now this thing was put together by a small prototyping firm in Japan, so like John-san, and they took drawings from what I had already produced, and then they produced another system. This is the antenna body here. The plate that goes on top, the sensing plate, is not installed. And then this here is the analog electronics that take those things in and then spits out output on the other side. So relatively simple. They should have been able to copy my design. What could possibly go wrong, right? And we took this thing out into Japan, and it worked. So this is our instrument. That was my boss in Japan. And over there on the right, that is a picture of lightning. This is actually a pretty cool picture of lightning. It was kind of published in like a ICAE newsletter, and that was it. We'll call that counting. This green stuff here, is an upward flash off of a wind turbine, which is pretty cool. And then this is the parent flash for it. I believe blue is before it and red is after. And these flashes were kind of crazy and low altitude, and they did all sorts of weird stuff that I never really quite figured all out. But the system worked. It worked in Japan. And so then we went on, and he found a customer who was dumb enough to, maybe try and buy one of these things. And we installed this in Singapore. And so here we are putting the antennas on top of the roof. I was a little bit worried about RFI in Singapore because, it's a big city, and these things measure VHF, and VHF comes off of all sorts of things like electronics that people run. And there's a lot of people in electronics in Singapore. I was a little worried about this, but we did it anyway. And we went through, that's us calibrating the locations of the antennas. And this system never worked. Absolutely never worked. I could not get this thing to work at all, and I could never figure out what the problem was. And I didn't figure out the problem until we took the same damn system out to Huntsville for this calculus system. And then it still didn't work. So we took all of the equipment into the lab there, and we started poking around at it and doing some diagnostics, and we found the problem. And this is, my instrument, and I'm going to explain this in terms of my instrument. What's going on here is that this power supply is running 24 volts. And John is going to say this is dumb, and it is dumb, so we're clear. But it worked. It's dumb and it worked. So this thing is 24 volts, but these guys over here, they want 12 volts. And so this regulator, which is bolted to the case because it's definitely going to get hot, is basically throwing away half the power and dumping it into heat to produce 12 volts for these systems. And the engineering team in Japan said, well, that's dumb. Why would you do that? And so they instead set this up to be like 12 volts. But the problem was that this is a DC voltage that's going down across a line. And as you pull power off of this thing, you're going to get a voltage drop across this line, a DC voltage drop across. This is just how this works. And if you use the lines that they provided, they tested that, and that worked. But if you make those lines longer, it stops working. And so to be able to do the kinds of deployments that we were looking at doing, we needed longer cables. And so that system wasn't ever going to function because these things would drop down below the minimum voltage that they needed to actually run the antenna. But this is a field project. We had to make something work, right? And we had a choice of either making the data worse, or we could beg and plead, and that's exactly what we did. We called Richard Sonnenfeld. You'll notice that that's one of my old antenna designs. And this is not my old box. We couldn't use my old system because that was actually also being used for this project somewhere else. But Richard had made a clone of it that was like mine but worse in every possible way. Because Richard had no money, and so he just did it with cheaper components and crappier systems. But his system functioned. So we did that. We took some data. I don't think we ever published that data. That's a real common thing in lightning. It's probably a common thing in a lot of sciences. But sort of kind of how that went down. As an epilogue here, my original system after that got moved out to Florida. And another student started working with that data. That is Julia Tillis, that's her name here. And she got a couple of publications out of that. And then Richard's system went on a little bit later to do at least one publication for a guy named Dan Jensen. Dan Jensen finished up his PhD last year. He did one publication on this, and he did like 3 or 4 more on a similar system that he built out of Los Alamos with a bigger budget. And this isn't actually all of it, because there's actually another clone of my system, which was built by Steve Cummer. I don't have photos of it, and so I didn't actually go try and figure out which publications were from it. But he got another 3 or 4 publications. So, you know, my original instrument had like 5 publications, then clones of it had another 5 or so. But you know what's missing here is I don't have any publications from that system in Japan. Like absolutely none. It was a complete failure. That system was a hunk of junk. So better come back to a moral here, right? Because I don't want to send you off and just say, you know, don't do anything good, it's going to work. But I do want to say that more expensive does not mean that it's a better instrument. If you guys look at a lot of these things that we were looking at, you know, just because you hire somebody like John to build you a thing doesn't mean that the thing John builds is going to work. And this has nothing to do with John either. John could do his job completely 100% right, but if you tell him to do the wrong things, it's going to fail. Because that's essentially what was going on in Japan. It wasn't that the engineering team there was like dumb and did a bad job. No, they did a pretty good job, and we just gave them incomplete specifications for what we were planning on doing. And when we deviated from what they tested, why would we expect it to always work? So the other half of this, the corollary to this, is test everything. You can't really trust it unless you can test it. And then definitely the hidden important thing to take home from this is that all instruments work better if you integrate some culinary apparatus. Even Steve Cummer did that. He built his out of pie pans. So anyway, that's all I got for you guys.
Questions for Mike? I think that is what you said just a second ago is probably the most common issue we encounter. And it's part of people that have come to the workshop that then end up working with us on projects later don't have that issue. We build something and they use it, and then they go, okay, now we want to make it do this. We go, if we had known that 6 months ago, this would be a very different conversation. But now that you're telling us this 6 months later, after there's our $100,000 instrument on your lab bench, we hope you have another $100,000 to build a whole different thing. So communicating requirements, very important. You don't tell somebody you're working with part of the story, they need the whole story.